All right. Hi, friends. Hopefully, we can get through this without any interruptions from my children. I wanted to just go over some things for your Module 10 test. The first thing that we need to talk about is a review of stoichiometry. Most of this we've been leading up to, building upon, but because we haven't done it for a few weeks, I know that some of you may be rusty, and a lot of our questions deal with all this background knowledge that you should have that has been building. So right now for this specific video, I am just going to be going over a review of stoichiometry, and then there are two specific questions on your test that deal with this process, and they're both worth 12 points. It's a very, each question has a lot that goes into it. And so I'm going to do two very similar questions, and the process is going to be the same. So hopefully you'll be able to apply this information to those questions on your test, and you can work it out on your own. And then I'll probably do a different video after this explaining molality and how we go about figuring that out, because that is a new thing that we learned this module that we didn't have time to talk about in class. Okay, review of stoichiometry. Before we actually begin a review of stoichiometry, we're going to, well, you know what, never mind, we'll do stoichiometry. Stoichiometry is, if you remember, is when we have grams of a substance and we want to turn it into moles. All right, basically that is the whole point of stoichiometry. We have a certain amount of something, perhaps we can weigh it, but we want to know how many moles. That's regular stoichiometry. So for example, let's say I had 20 grams of H2O, which we know is water, and I want to turn it into moles. How do I go about doing that? Very simple. It's one conversion formula problem. All right, so we take our 20 grams of H2O over 1, multiply it, and now over here we want to end up with moles, so moles goes on top. We want to get rid of grams, so grams of H2O go on the bottom. Now, how do we know what to put here? That's where we go to the periodic table and we find the weight of each one of these things and add it together. So hydrogen is 1.1 grams per molecule, right? And so, not grams. And there's two of them. And then oxygen is a 16.0. So we're going to add all that together, which gives us 18.02. So that is what we're going to put right here. That is probably the part that you may forget. You're like, how do I get this number over here? You just look at your periodic table and add whatever this is up. And that is per 1 mole. So you just put a 1 up here. So what you have to do, this is going to cross out, this is going to cross out. This is just a division problem. If you were typing this into your calculator, you would type in 20.0 divided by 18.02. And what you should get is something that looks like this, 1.1098 number. Okay, and so how do I know when to round this, where to round it off? Do I round it here, 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 here? Look at your beginning number. Significant digits, right? Really, the significant digit here, I didn't have to have a 0.0, but they added a 0.0. So I can have 3 significant digits right here, which means that my answer needs to have 3 significant digits. So my answer is 1.11, I'm sorry, 1.11, I got to round correctly, moles. All right, so that was a quick review of stoichiometry from grams to moles. That's how you do it. We're going to use it in these problems coming up. All right, so review, after we learned moles, we learned about something called molarity. And it's represented by a capital M, molarity. And molarity is pretty simple. It's just the number of moles that you have divided by the number of liters of whatever it is. So it's just one division problem, but you have to have something in moles and you have to have something in liters. And the tricky part is almost every single problem will give you milliliters, and you have to convert it to liters to do this problem or it will not work properly. So keep that in mind. Always be looking to see, does it start off in liters or does it start off in milliliters? Okay, so let's say we want to find out what is the molarity. By the way, molarity also means concentration of. So if you're like, I don't even know what that means. Concentration of. What is the molarity or the concentration of H2O, water, in a 4 milliliter bottle of some kind? Question mark. Wow, I spelled that wrong and I don't know what I'm doing. There we go, bottle. Okay, so easy peasy, we just figured out what the molarity of water is. So I can use that here. However, this is liters, they gave me milliliters, so the first thing I'm going to need to do is change 4 milliliters into liters. How many milliliters are in 1 liter? 1,000, right? So this is just a division problem. Once again, 4 divided by 1,000 is going to give us 0.004 milliliters. So I have that, and that's gonna, liters, that's gonna go right there, okay? So I know my moles, I know my liters. I'm just gonna set up a problem. 1.11 moles of H2O divided by 0.004 liters, and that's gonna give me my molarity, which ends up being 275. All right, hopefully you got that. That is my review of stoichiometry and molarity, and now we're going to move on to our first problem. Move my paper out of the way, get my next paper with, I got the problem pre-set up so I don't have to write it and take forever on this video. I may end up needing more paper, but that's okay. All right, here's our question. Potassium cyanide is made up of potassium and oxygen and hydrogen, and you add hydrogen and carbon and nitrogen, and it yields water and this right here, potassium cyanide. Okay, if you need to make 25 grams of potassium cyanide, how many milliliters of a 1.51 molarity solution of HCN would be required? All right, so first let's look and see what we have. This is helpful. We know that we have 25 grams of potassium cyanide. We know that they're looking for how many milliliters. That's what the answer needs to be. The answer needs to be in milliliters, whatever we find out. How many milliliters of, we know that we have a 1.51 molarity solution of hydrocarbon nitride would be required. Okay, so we have all this information. Let's look and see what we need to do. All right, I want to get milliliters. I know if I have molarity, then I know that that is moles over liters. So if I could figure out what the liter part of that is, I could probably figure out the milliliter part. All right, so first what I want to do is let's go ahead and take 25 grams of potassium cyanide, okay, which is KCN, if you weren't sure. There we go, KCN, which is this right here. And let's find what our moles are of that. All right, let's change grams into moles. Honestly, in most every single problem at this point, you're gonna need to get things into a mole situation. So let's just go ahead and do that. All right, I have 25.0 grams of KCN, all right? and I want to change that into moles, so I'll put 1 mole. I'm going to put KCN, and now remember, you go to your periodic table, and we're going to see what these numbers are, and we're going to add them all together. It's the atomic weight. It's the little number that is literally right under the letter. All right, it's not the number on the periodic table. You know, like hydrogen is a 1, but the weight is 1.01. So you're looking for the number that's right underneath here on the periodic table. So I already have that written down over here. It is 65.1 grams. All right, so now I can figure out my molarity, cross this out, cross this out. This is just a division problem. 0.384. I'm going to do 3 significant digits because this is 3 significant digits and this is 3 significant digits. All right, so I have 0.384 moles. Stop, I'm busy right now. All right, yep, and the 2-year-old found me. Okay. Of KCN. All right, so now I have those moles, which is great. So now that we have moles, we're going to do some more stoichiometry, which we didn't really talk about before, this part, but it is part of stoichiometry. Let's look up here. Remember, these coefficients are really important in stoichiometry. So right now, this is 1. And this is 1, and this is 1, and this is 1. All right. Now, if these had a number in front of them like 2 or 3, that would also be important, and we need to know that. But right now, there is no number in front of these, which means this is only 1 molecule of this, and this is only 1 molecule of that. All right. So the next thing we're going to do is we're going to say, if we have 0.384 moles of KCN, let's figure out how many moles of HCN we have, because that is what we're looking for. Okay, so I want to end up with moles of HCN right here. Okay, I want to get rid, let's do moles. I want to get rid of moles of KCN. I can't like talk and write at the same time, right? And if we look at the ratio up here, we can see that for every one of these molecules, it yields one of these molecules, which makes it really simple for us. We just put a 1 here and a 1 here. Is this coming back to you? Do you remember when we did this? All right, and so what we're going to do, we're going to cross this out. We're going to either multiply by 1 or divide by 1. It's your choice because it ends up being the same number, which is 0.384 moles of HCN. Okay, we're getting there. Now remember, we want to figure out how many milliliters of a 1.51 molarity solution of HCN there is. Okay, so we need to now set up one final problem. Well, actually there's one almost final problem. We'll take our moles of HCN, right? We are going to figure out the liters. How many liters? All right. We're going to use this number here, 1.51 molarity. I'm sorry, moles. HCN. Cross that out, cross that out. Oh, this is a 1, I'm sorry. So for every 1 liter, you may be wondering, Miss Wilson, this says molarity and this says moles. Why did you write it like that? Okay, because keep in mind that molarity is the number of moles divided by the number of liters. All right, and if we have 1.51 molarity, and we don't know this, but we do know that we're just talking about 1 liter, then that's going to end up being the same number, 1.51, and it's going to be times 1. So it's the same thing. So the number of moles is 1.51. Does that make sense? We skipped a step, but that's why. Okay, hopefully you understood that. So now we're going to take this number, we're going to divide it by this number. It's going to give us 0.254 liters. Is that what we want our answer to be? Negative. So let's do one more problem where we're going to turn this into 1 liter. Gives me 1,000 milliliters. So we're going to do a multiplication problem, which gives me 2.54 milliliters. And that is how you do this problem. Okay, so the hardest part of these problems, I believe, is knowing what do you do next. I can do this across stuff. I can find this number. I can figure out my coefficients, but like, how do I put it all together? Right, so there is a question on your test. I think it's the very first question that you have to do a problem with, like this, where it's going to be set up very similar. It's going to ask you if you need to make a certain gram of something, how many milliliters of some kind of molarity solution would be required. It's going to be set up just the same. So you're going to do the same steps to get there. And you may even have to do this little step over here to the side, but I'm sure you can handle it. All right, so that is one question on the test. And now we're going to move on to question number 2 of our review here. All right, I can't, y'all, I'm not even going to attempt to try to pronounce what these things are. But the following reaction is performed in a lab. This molecule plus this molecule is going to yield this molecule and this molecule. I'd like you to see our coefficients here. And this one doesn't have one, so it's just a 1. That may be important, or it may not be. But I'd just like to show you before we begin, these coefficients are not all 1. So that would be something you might want to think about. All right, it says, if 300, my marker didn't make that very clear, if 382 milliliters of a 1.25 molarity aluminum nitrate is added to an excess, meaning extra, right, of potassium carbonate, how many grams of aluminum carbonate will be produced? Okay, so I feel like the first thing I want to figure out, again, is what are we looking for? What is the answer to this problem? We are looking for how many grams of aluminum carbonate. Now, aluminum carbonate is this thing right here. I'm going to just put a little arrow. That is aluminum carbonate. Right? And aluminum nitrate would be this guy. Put it down so you could see. Aluminum nitrate. It's important to know what these things are, because if they tell us we have a certain amount of them, we need to know what we're talking about, right? All right, so let's do it one more time. If 382 milliliters of, okay, so we know we have milliliters of this thing, AlNO33, of this molarity is added to an excess of potassium carbonate, which would be that, added. How many grams of aluminum carbonate will be produced? So we're looking for grams of aluminum carbonate. That is our end point. All right, so first thing first, just like before, let's get something into moles. What do we need to get into moles? We first must get, oh, no, yes, we do have moles. Let's change 1.25 molarity of aluminum nitrate. Let's find what moles do we have in that. Do you remember how we did that before, right? We knew that molarity is number of moles over number of liters. We just want to find 1 liter, right? So we have 1.25 m. No, I don't want 1 liter. I want this many liters. But that's in milliliters. So let's change that really quick. We have 382 milliliters. We want to get rid of milliliters. We put it on the bottom, put liters on the top. Okay. 1,001. All right, so that's going to give us 0.382 liters. Okay. Now, I have this. I want to know moles. I don't know what the moles is, but I do know that I have this, and I don't know this. All right. So we're going to multiply those numbers together, and that's going to give us 0.478. I'm going to put moles here because that's what we're looking for. Moles of AlNO33, which again is aluminum nitrate. Okay, and it told us that that was aluminum nitrate. So now we have some more information. We now know the milliliters of aluminum nitrate. We know the molarity of aluminum nitrate. We now know the moles of aluminum nitrate. What we don't know is the grams. Do we need to know grams? Well, we need to know grams of aluminum carbonate. So let's see how else we can get there. Okay, now that we have moles, last time, if you remember, when we knew the moles of one thing and we wanted to know the moles of another thing, we had to look up here and look at the coefficients and create a stoichiometry problem where we set up a ratio. All right, so let's start off by just writing, we have 0.478 moles. Oh my goodness, this is so long. There we go. And we want to get rid of the moles of aluminum nitrate, but we want to find out the moles of aluminum carbonate, because if we can find the moles of aluminum carbonate, we can kind of go backwards and figure out the grams. So I'm going to put moles of aluminum carbonate. Okay, so now let's go back up here. We're going to look for the coefficient numbers in front of each one. All right, so let's look at carbonate, and then we'll look at nitrate since kind of in that order. All right, so carbonate has a 1, and nitrate has a 2. All right, so carbonate has a 1, and nitrate has a 2. Okie dokie. So we're going to cross this out. I forgot to put my over 1. All right, when it's set up this way, it's 0.478 divided by 2. So that is going to give me the moles of the carbonate, aluminum carbonate, and 0.478 divided by 2. What's my math over here tell me? 0.239. Okay. Hooray! I now have the moles, but I want grams. So I need to do one final thing. Do I have room for it? I think I do. All right, so I'm going to set up moles. Oh my word. It's like the longest molecule ever. All right. And we want to find grams, remember? So I'm going to put grams up here at the top. because that is what I want to find. I don't even know what I'm writing at this point. Lots of weird looking 3s. All right. So for every mole of aluminum carbonate, how many grams do I have? Well, remember, this is that problem where you have to look at your periodic table and you have to say, how much is aluminum? Well, I need 2 of those, so I need to multiply that by 2. Over here, notice I have a 3 outside here, so I need to figure out how much carbon is, multiply that by 3. Oxygen has a 3 and a 3, so that's like 9. So I need to find out how much oxygen times 9. All right, so aluminum times 2, plus carbon times 3, whatever that is, plus oxygen times 9, whatever that is. And if you add all that up, you're going to get 234.0 grams. Okay, I'm going to get rid of my moles. Get rid of my moles. I'm going to multiply across, because that's how that's set up. And I'm going to get 55.9 grams of aluminum carbonate. Lord have mercy. You'd think after all I'm writing, I would get it right. Notice that this is 3 significant figures. Let's look up here. I have 3 significant figures in my problem. 3 significant figures in my problem, which means my answer needs to have 3 significant figures. All right, that is how you do this problem. Again, you're going to have a very, very similar problem on your test. This is the way that you're going to set it up. I'm sure you could take screenshots of this and keep it up next to you so you kind of know the order of what you're doing. However, these are not the numbers, and these are not even the molecules. It's a whole different set, but the process is the same. All right, so you're going to need to do the same process to get your answer. All right. I'm sure that when you type it into the test, it'll tell you it's wrong, even if it's right, because if you just put a space in a different place, if you capitalize the G, if you don't put a parenthesis where it needs to go, it tells you it's immediately wrong. So don't stress at first. I will be going and looking at them and checking them and letting you know if, normally if this is correct, all this gobbledygook behind it, I say forget that, and I just give you all the points, okay? If you don't round it exactly correctly, I normally take off like 1 point, right? If it's a whole different number, the frustrating part is I can't see your work, so I have no idea what you did wrong. This is a 12-point question, so it's like you're either gonna get 0, 11, or 12 for this question, depending on what you type in. All right, so that is the end of the 2 very, very long problems. I think there's one more long one later on, but I'm going to make another video and post it on molality and how to figure that out. All right, so watch this video, do that part of the test, watch the next video.